Dear students, welcome to the lecture series on robotics. I am Dr. S.J. Doshi. Today, in the first lecture of Introduction to Robotics, we will discuss how robotics emerge as a branch of engineering, progress of robotics, 3 laws of robots, and present-day utilization robots in industry. When we think of robots, we often think of shiny metal, flashing lights, and complex code. But did you know that the word robot didn't come from a lab? It came from a stage. In 1920, over a century ago, a Czech writer named Karel Apek wrote a play called RUR, Rossum's Universal Robots. Interestingly, his robots weren't made of gas, they were biological, artificial people built in a factory. They were meant to serve, but as is common in science fiction, they eventually rebelled. It took us another 40 years to move from that biological dream to the industrial reality we know today. The timeline of progress. To understand where we are, we have to look at the 3 great eras of robotics. 1. The birth of the name, 1920-1950. This was the era of imagination. After Apek gave us the name, filmmakers gave us the image with Maria, in the 1927 film Metropolis. Then came the first physical attempts, like Electro, a 7-foot-tall robot that could walk and talk via a record player. Perhaps most importantly, in 1942, Isaac Asimov coined the term robotics and gave us the 3 laws, teaching us that as we build these machines, we must also build an ethical framework for them. 2. The Industrial and I Revolution, 1950-1990. In 1954, George DeWaal patented Animate, the world's first programmable industrial robot. By 1961, it was working at General Motors, doing the dirty, dull, and dangerous work of handling hot metal. We soon saw the Stanford arm bring precision and Shaky the robot bring reasoning through sensors. Robots were no longer just characters in books, they were employees on the assembly line. 3. The modern era, 2000 present. Today, robots are everywhere. They are in our living rooms, the Roomba, they are on other planets, NASA's Curiosity rover, and they are working right next to us as cobots, in hospitals and warehouse. Automation versus robotics, what's the difference? We often use these terms interchangeably, but there is a distinction. Automation is the broad umbrella. It's the use of systems to control production. Robotics is a specific form of industrial automation. Within the industry, we look at 3 types. Times fixed automation, think mass production. Low variety, high volume. Times programmable automation, for when you have a moderate variety of products. Times flexible automation, the gold standard, where we can handle high variety without stopping to retool everything. The anatomy of a robot, mechatronics. So, what actually is robotics? It isn't just one subject, it's a symphony of 4 major fields. This synergy is what we call mechatronics. 1. Mechanical engineering. This provides the body, the structure and movement. 2. Electrical engineering. This is the nervous system, the circuits, power, and sensors. 3. Computer science. This is the brain, the logic and the algorithms. 4. Artificial intelligence. This is the intuition, allowing the robot to learn and adapt. Conclusion, the simple formula. To put it simply, you can remember robotics with this formula. Robotics is equal to mechanics plus electronics plus coding plus control. we have come a long way from the biological workers of Karel Apak's imagination. Today, robotics is about creating intelligent systems that take on the tasks that are too repetitive, too hazardous, or too complex for humans, allowing us to focus on what we do best, creating and dreaming. Defining the robots. The challenge with defining a robot is that the definition changes depending on who you ask. In 1969, the Robotics Institute of America gave us a very technical, industrial perspective. They defined a robot as a reprogrammable, multifunctional manipulator. To them, the magic was in the versatility, the idea that you could change a machine's purpose just by changing its code. If you look at Webster's dictionary, you get a more human-centric view. They describe a robot as a machine that performs functions normally ascribed to humans. This is where we get the idea of the android, or the humanoid form. However, the most modern and perhaps most accurate definition comes from the ISO, International Organization for Standardization. They describe it as a programmed actuated mechanism with a degree of autonomy. That word, autonomy, is the secret sauce. A robot isn't just a tool we push, it's a machine that, to some extent, moves and decides for itself. To truly distinguish a robot from a simple automated tool, like a toaster or a power drill, we look for a specific three-step cycle. This is the DNA of robotic behavior. 1. Sense. The robot must gather data. It uses eyes, like cameras, ears, like microphones, or skin, like pressure sensors to understand its environment. 2. Think. This is where the computer brain takes over. It processes that sensory data, compares it to its programming, and makes a decision. 3. Act. Finally, it carries out a physical movement using motors, wheels, or grippers. Think of a robotic vacuum. It senses a wall, touch, thinks, I can't go through that, and acts by turning around. If a machine cannot do all three, it's just an automated tool. A toaster might act by heating up, but it doesn't think about the bread, it just follows a timer. The moral code, Asimov's laws. As robots move out of the lab and into our streets and homes, we have to ask, how do we keep them safe? Long before we had the sophisticated eye of 2026, the sci-fi visionary Isaac Asimov realized that robots needed a code of conduct. In 1942, he proposed the 3 laws of robotics, which he imagined were hardwired into a robot's very soul, its positronic brain. Times the first law. Highest priority: a robot cannot injure a human or allow a human to come to harm through inaction. Times the second law. A robot must obey humans, unless those orders conflict with the first law. Times the third law. A robot must protect itself, as long as that doesn't break the first 2 laws. Asimov eventually added a 0th law, a grander vision stating that a robot must not harm humanity as a whole, even if it means an individual might be caught in the middle. These laws aren't just fiction anymore, they are the foundation of how we discuss ethics and safety in our modern world. The global explosion in usage of robot in last decade. The data shows that we are currently in the middle of a global robotics boom. If you look at the operational stock of industrial robots worldwide, the numbers have surged from 1.3 million in 2013 to nearly 4.3 million in 2023. Times China's dominance. China is the undisputed leader, installing over 276,000 industrial robots in 2023 alone, more than all other countries combined. Times India's rapid rise. For those of you looking at the domestic market, India is currently seeing the fastest annual growth in the world at plus 59%, adding 8,510 new robots in 2023. Times industry shift. We are seeing a steady transition toward full automation in everything from automotive plants to food processing.